Hi, in this video we will introduce the simplification rule. We will talk about how to apply the rule, how not to apply it, what mistakes to watch out for. Hi, this is Logic Self-Taught with Dr. Phi. In this video we will talk about the simplification rule, how to apply it and how not to apply it. I presuppose that you already know the conjunction rule. The simplification rule allows us to simplify a conjunction, i.e. to add one of its conjuncts to the proof. So basically, if you have a conjunction in your proof already, however complex, you're allowed to add one or the other of its conjuncts to the proof. Let's look at the rule in symbols. We have P and R on line 5. We can add another line with the first conjunct to the proof. We'll justify the line citing the simplification rule and the line number where the conjunction is. We can also derive the second conjunct by simplification, and we cite the same line. So there are two ways to do it. The simplification rule is quite intuitive, as is shown by the following examples. Jim will get a D in English and he'll be upset. Surely we can infer that Jim will get a D in English. We can also infer that Jim will be upset. This is just what simplification allows us to do. Here's another example of a more complex conjunction. Mark will not pass logic, but he'll be happy if Susie loves him. We can surely infer that if Susie loves Mark, he will be happy. This is a relatively uncomplicated conjunction. We can derive the first conjunct by simplification or second conjunct, here not C. Let's look at a more complex case. Again, we have a conjunction here. It has two conjuncts. We can derive either one. The first conjunct, this will be a conjunction, or the second conjunct. This is a negation of a disjunction. Bear in mind, we take the whole conjuncts. Simplification basically allows us to derive the components of conjunction. But frequently students generalize this rule and apply it to other complex propositions. If we have a disjunction, we can't simplify it, and this works for all the remaining connectives. For conditionals, for biconditionals, you can't apply simplification to them. Inference rules see only the main connective. Remember, they don't apply to proposition components. The following proposition is a conditional. Its antecedent is a conjunction. We must not apply simplification to a component, an antecedent in this case. When simplification looks at this proposition, it doesn't see the conjunction. All it sees is the conditional. What if we had a different example? This time we have a conjunction. Can we apply simplification to get B in this case? Clearly not. The same problem affects this kind of application. We cannot apply simplification to a component. The simplification rule sees a conjunction in line 1, but the conjunction has only two conjuncts, C on the one hand, and the conjunction of A and B on the other. So we can apply simplification here, but we can only derive the whole first conjunct. Now that we have derived A and B in line 3, we can apply simplification to that line and derive B. This is Logic Self-Taught. It's exercise time. Do all the exercises until they feel like a breeze.